Hi there. Let's talk about dilutions. For this one, I put it in a beaker, sodium chloride, that's a solute. And then you add some water, that's a solvent. Solvent is water normally, right? So those are the two things we need to talk about dilutions and calculations. So what happened to the sodium chloride? That's going to break into ions, plus and minus cations and anions, normally metal cations and non-metal anions. So it's going to break into pieces and that'll go in between the water molecules. We call the solvent cage. So this breaking of the sodium chloride into sodium plus aqueous and chloride minus aqueous is called the dissociation. So this is a spontaneous process, dissociation. I call it disassociation. That breaks into two things, right? They were associated together by the electrostatic forces, but the thermal energy of the water will break into that, right? Now what happens? Solvent and solute together makes a solution. So we are going to talk about the solution strength calculations, right? So how much of solvent, actually how much of solute divided by the how much of solvent, because the solvent is the larger portion, right? Solute is the smaller portion. So now we are going to look at this, how many particles of solute in a larger portion of how many particles of solvent, right? Now, so to be precise, we will be only talking about the molarity. In the molarity, it's important um, for the explanation and also for the formula to know the definition. So the definition is actually number of solute moles divided by the liters of solution. So that is important. So that means moles of solute divided by the liters of solution. So simply for the math, we just use moles divided by L. Big L is equal to molarity, which is big M. So simple N divided by big L is equal to big M, right? So that's the easy way to do math. So simple N divided by big L is equal to big M. So now you will know two of them. You're looking for the one which is unknown, right? So you have to manipulate that. Now, so remember, liters are solution, not the solvent. The solvent is the pure version of it, right? So the solution is the two things together. Now, normally the number of moles are smaller values and the solvent amount is normally larger. That's how normally a solution should look like, right? Now, we also can look at how to illustrate the dilution and mixing. So actually, yeah, mixing dilutions, we are not going to talk about that one. We just talk about the sodium chloride dissociation and the how do we know the ion molarities. So this one in gives you one sodium plus and one chloride minus in the dissociation. So like I said, remember it's a spontaneous process and and it makes one sodium 1 chloride. If you take calcium chloride, it'll make one calcium 2 plus and two chloride minus. Now why? Because there's Cl2. Look at this one. K3PO4 will give you 3K plus and one phosphate PO4 3 minus. The reason is we have to look at this way, right? We have to look at, see the K3, the 3 comes to the front as a coefficient. Chloride 2, the 2 comes to the front. So that's how you get them, right? So that's an important thing. The other thing is sometimes students have the question like, how do I get 1 mole breaks into 1 mole and 1 mole? That doesn't work. No, it does. X molar, X molar, X molar. How? See the plus and minus together, you separate the plus and minus as in pink, and then you get the two pieces. Look at this one, X molar gives you X molar calcium and 2 times of X molar chloride. You can visualize it this way. So the calcium 2 plus is this little diamond, and then the two little balls each side is the two chlorides minuses. So you can write it 1 calcium 2 plus and 2 times of the chloride species, right? So that's what you have to see. So you try to visualize it if you have trouble figuring out how did I get this x molar, 3x molar of K plus and just X molar of phosphate. You have trouble, just draw it and try to make sense of it, right? Now, this is the big equation, the other thing we will be using. M1V1 is M2V2, simply before the molarity and volume, and after the molarity and volume, that will be equal. So that's the formula we're going to use. In this case, it's important the molarity is given moles per liter and volume is given in liters. But in the math, there's little tricks you can do. Okay. Now, if I'm looking for M1, just M2V2 divided by V1. If I'm looking for V1, divide by the M1, right? The reason is simply it's a cross multiplication. So you just have to get the M1, you have to divide both sides with the V1. And if you want to get V1, you have to divide both sides with M1. So that's what we have done, right? So it's a bit of algebraic manipulation, right? Now, if I'm looking for M2, you have to divide by the V2, the other side. If I'm looking for V2, you have to divide by the M2 other side. So just practice a little bit of this manipulation of this formula is important rather than putting the numbers in it and make it complicated, right? So that's the formula, and all based on M1V1 M2V2. Now, how do we make sense of adding water and taking water away, making diluted, making concentrated? This is how we make sense of it. So if I have a solution of M1 and V1, some molarity and some volume, if you take the water out, minus water will make it concentrated. That means M2 will be higher and the volume 2 will be lower. That's how you make sense of it. If you add water into this green cage, you added water, so you'd make it diluted. That means M2 goes down, the volume V2 goes up. That's how you make sense of it. This picture is actually really important to understand. When you add water, when you remove water, what happens, right? So this question, we're going to do it separately, actually. So I have a bunch of questions to discuss in a different video, but it's important here. M1V1 is equal to M2V2. That's the one we're going to use for any calculation, most of the simpler calculations, right? Remember, make sure you have same units. If you have milliliter, you can still work on it. But normally, big M and liters are the ones to go, right? Now, what you do? Manipulate the M1V1, M2V2, plug in, and then you add the numbers into that and do the math. Now, if you ever want to know how much of water added or taken out, that is actually V1 minus V2.